All right, today we are continuing with section 6. Remember last time we talked about confidence intervals and we started talking about hypothesis testing. We talked about the null and the alternative hypotheses and how to tell which one is which. So now we're going to talk about actually testing those hypotheses. Okay, so once I make a claim and I identify my null hypothesis and my alternative hypothesis, I collect a sample, I analyze it, and then there's some very specific statistical vocabulary here. I either reject the null hypothesis or I do not reject it. Okay, so notice we don't say reject or accept. Just because I reject the null hypothesis doesn't necessarily mean that the alternative hypothesis is true. It just means that I have to reject the null hypothesis. There may or may not be enough evidence to accept the other hypothesis. That's farther on. So right now we just say reject or not reject. How do we decide? Well, first we find our sample mean and we have to figure out if it falls in what we call a critical region. A critical region is basically a range of values that tell us, okay, this mean is different enough from the mean that I think I have to reject the null hypothesis, to say, okay, the null hypothesis, I can't necessarily say that it's true. We determine the significance level alpha. Usually we say we're going to do it at 1%, 5%, or 10% significance. So it's determined by that and also by the inequality sign of the alternate hypothesis. So there are 3 tests we're going to focus on. The left-tailed test, so notice if my alternative hypothesis says that the mean is less than something, I'm going to do a left-tailed test. And my critical region will be down here. If my alternative hypothesis says the mean is not equal to something, I'm going to do what we call a two-tailed test. And my critical region is going to be split in half between the top and bottom part of my normal curve. And if I say that the alternative hypothesis is that the mean is greater than k, I'm going to do a right-tailed test. Okay, so basically what does significance level mean? You might be asking, how do I figure out the significance level in my critical region? Basically a significance level, if we're going to say, let's use 5% as an example, a significance level of 5% means that we need the data to show us enough evidence against my null hypothesis so strong that the data would occur no more than 5% of the time if it was true. So we're saying if my null hypothesis is true, this data would only occur 5% of the time. So I would reject the null hypothesis because that's not enough. All right, z-values and z-statistics. When we are hypothesis testing, we use the z-values that we saw in the last section, in section 5, to figure out our critical region. We calculate then our z-statistic to figure out if our sample mean, the mean that we calculated from our data, falls in the critical region. If it's in the critical region, we say, okay, we're rejecting the null hypothesis. What we're doing in this section is known as a z-test. There are other kinds of tests that we're not really going to look at. Once we find the area that corresponds to whichever significance level we want, 5%, 10%, or 1%, a z-statistic for the sample mean is calculated. The z-statistic is the z-value for our sample. When we test at 5%, it is only 5% likely for the z-statistic to fall in the critical region. So if it does, it's only 5% likely for the z-statistic to fall in the critical region and the null hypothesis to be true. So when I test at 5% significance, I'm saying, okay, there's only a 5% chance that my z-statistic would be in the critical region and my null hypothesis would be true. So if our z-statistic is in the critical region, that's why we reject the null hypothesis. There's only a 5% chance it would be there. All right, so here are my steps for hypothesis testing. We state the hypotheses and we figure out where the claim is. We find the critical values and the critical region. We're going to use our calculators to help us do that. We find our z-statistic with this formula. The sample mean minus the population mean over the standard deviation over the square root of the sample size. And then we decide if we reject or fail to reject the null hypothesis, and we make a conclusion about our claim. So let's take a look at an example. Again, the vocabulary here can be a little confusing, so make sure that you follow with me, re-listen if you need to, make notes to yourself. So here in this example, Jenny thinks there are more than 10 pages of advertisements in every issue of a particular magazine. We're going to use a sample of 42 magazines. She calculated a mean of 10.5 pages, that's my sample mean, with a standard deviation of 1.6. We're going to test our hypothesis at a 1% significance. So we're going to go through this step by step. Step 1, we find our claim and our hypotheses. So here, she's saying more than 10 pages of advertisement in every issue. That has to be our alternative hypothesis because there's no equal sign. Our null hypothesis would be the complement. The mu or the mean is less than or equal to 10. My claim is in my alternate hypothesis here. Step 2 is to figure out the critical region. The alternative hypothesis is greater than 10. So if you look back at the chart with the tails, that means that we're going to use a right-tailed test because the alternate hypothesis has a greater than sign. We're testing at 1% significance. So what we have to do is find the z-value that goes with the upper 1% of my normal curve. So in your TI Nspire calculators, in your calculator screen, you go to Menu, Statistics, Distribution, Inverse Normal, and you put in the area you need. In this case, since we're testing at 1% significance, we need the upper 1% of our distribution. So that means that we're going to, since I want the upper 1%, when I do this in my calculator, it's going to say like inverse normal, and I'm going to plug in 0.99 because 1% is bigger than 99% of the rest of my data. So here's 99%, and here's my 1%. So I put in this number as a decimal, and it gives me this z value, 2.326. So we're going to calculate the z statistic then for this sample data. Here's my formula, and you should be able to look at that back in that key concept box as well. So my my sample mean is 10.5. Yet another typo, this should be 10. My sample mean is 10.5. My hypothesized population mean is 10, so what I think is going to happen is 10. Standard deviation 1.6, and n is 42. So I plug that in, and I get 2.03 as my z statistic. That's step 3. So notice my critical region is here above 2.326. So if my z statistic falls in here, I would reject the null hypothesis, but 2.03 is to the left, so it's not in the critical region. My z statistic is not in the critical region. So we say, again, we do not say accept, we say we do not reject the null hypothesis. We might need more evidence to prove if it's true, but we don't reject it because the z statistic is not in the critical region. And so remember that our claim was actually in the alternate hypothesis. So since we did not reject the null hypothesis, that means there's not enough evidence to support the claim because her claim was in the alternate hypothesis. Okay, you guys try this one. All right, you should have gotten B. There is enough evidence to support her claim. So basically here your null hypothesis should be that the mean is greater than or equal to 150, because that's what Kate is claiming, that it's usually read for at least 150 seconds. So my claim is in my null hypothesis this time. My alternate hypothesis would be that the light is read for less than 150 seconds. When you get your critical region, you're using, since I'm testing at 5% significance, in your calculator use 0.95 with that inverse normal function, and we get that my critical region is up here. So when you calculate then your z statistic, it should not fall in the critical region, so we will fail to reject the null hypothesis. Since we fail to reject it, there is enough evidence to support her claim. All right, sometimes we're going to do a two-sided hypothesis test. A label on a package of food states that there are 120 calories per serving. If we use a sample of 38 servings, so that's my N, Libby calculated a mean of 120.6 calories with a standard deviation S of 2.2. And we're going to test again at 5% significance. This is what she is thinking her mu, or her population mean, is 120 calories per serving. So here our null hypothesis would be that our mean equals 120. And notice my claim, that is my claim, so my claim is in the null hypothesis. My alternate hypothesis is everything else, so the mean does not equal 120. The critical region is determined by the alternate, or the alternative hypothesis. Since it's a not equal to, it's a two-tailed test. What you have to be careful of in a two-tailed test is, since we're testing at 5% significance, we have to split that 5% into the two different tails. So I need 2.5% to be down here and 2.5% to be up here. We need to find the z-value that goes with that portion of the distribution. When we use our calculator to do that, when I do inverse normal, notice I do it of 0.025. That's 2.5%. That gives me the critical region down here, all of the area above 2.5%. And then to get the critical region up here at this part, I do 97.5%, because that's 100% minus 2.5%, which is 97.5%. So that's the area I need up there. I get my two z values. And they should usually be, I think, just opposites of each other. So now we're going to calculate the z statistic. There's my formula again. So I take 120.6, that was my measured mean, or my sample mean, minus the mean that I think is going to happen, divided by 2.2 over the square root of 38. Should be 2.2. Okay. Calculate that and I get 1.68. So notice what happens. 1.68 is not in my critical region. It's below my critical region. It falls in the non-critical region there in the middle. So since my z value is not in the critical region, I do not reject my null hypothesis. I do not reject my null hypothesis. So there's not enough evidence to reject the claim that there are 120 calories per serving. Wow, there's a lot of typos here. Per serving. Again, remember my claim this time was in the null hypothesis and I didn't reject it. So I can't reject the claim about 120 calories per serving either, because that falls in my null hypothesis. Okay. All right, last one. All right, you should have gotten A, that there is not enough evidence to reject the claim. All right, and these should have been the null and alternative hypotheses that you wrote down. Your claim is in the null hypothesis. These are the two z-values for your two-tailed tests that determine your critical region. Then you should have found the z-statistic. And from there, you should have found out that there is not enough evidence to reject the claim. So you should have failed to reject the null hypothesis. All right, that's basically the end of this section. We'll be doing some practice with this in class. So don't worry, just make sure you pay attention really closely to the vocabulary and what you need to do and the 5 steps for each piece of the process.